Let me take off my mask. So, hi everyone, I'm Shen. I look after products at HTC. It's actually a true pleasure for me to be here at Computex 2022. So, as introduced, I'm going to talk about XRs and its place when it comes to the metaverse. So let's start off, whoa, that's not what I wanted. So let's start off with metaverse as a whole, right? It's the hot word in the media. At HTC, we actually agree it's a little bit overstated. So, because we've actually always been in a metaverse of some sort. It's made up of different components, but it's always existed, right? When you use your smartphones, the web, streaming, online gaming, those are part of the metaverse, always have been. So our strategy has always been to dream bigger than just ourselves. We want to open up platforms created by the people, owned by the people, and shared by the people. So we call this Viveverse, which is our place in the metaverse, an immersive, boundless universe of fantastic new experiences, and other universes in collaboration with our partners. But to access it, we need to talk about human interfaces. And today, specifically, I'll talk about XR. And I'll go through some of how we see the XR market. So at HTC, we have we see three main tiers when it comes to VR technology. You have PCVR, all-in-one VR, or AIO, and also a new thing that we've been looking at called immersive glasses. Let's start off with PCVR. Right? PCVR is for the people that want the most when it comes to performance. So we'll take a look at how it's being used. Right? So here we have Bugatti. Right? They want the highest of graphical fidelities. Right? Bugatti and countless automotive OEMs have been evolving their design processes. Being able to create and alter designs in a virtual studio right in front of them. The level of detail that they require, they have to see every single component, how they fit, how they look under different lighting conditions, down to the stitching on the individual leather seats. That's how detailed they're looking for. That's how much detail they're looking for. So no longer do they need to build those traditional, but both time and monetarily expensive clay models just to view a concept in life size. They can now do it in real time on a virtual life-size model right in front of them. This has led to them being able to accelerate the development quite significantly. One of our most successful customers when using VR to accelerate design and product development has been Bell Helicopters. So Bell Helicopters, they were starting to concept a new revolutionary helicopter design, the FCX-001. They had expected their normal development time of around 5 to 7 years. This is down to how they iterate on their designs with a new architecture, fabricate new prototypes, test, get feedback from pilots, engineers, and then repeat that until it's good enough. With VR, they were able to tweak things like in real time with responses from engineers and pilots straight there. Maybe you want to move a part of the chassis so it removes a blind spot. This sped up their development time from that 5 to 7 years all the way down to 6 months. Let's move on to the AIO category, where all of that processing power is embedded right inside the headset, so it can work standalone, without the need for external computing or power sources. While leveraging mobile computing technologies, there are huge benefits when it comes to ease of use and portability. Aside from being very accessible for more consumers when it comes to gaming, it's also started being integrated into professional training and onboarding processes as well. Here's the health and safety training scenario with Out Here and the global construction company Skanska. It's a real training demo that was designed for our Vive Focus 3, used to teach people to be more aware of their surroundings on a live building site, as well as training on actual tasks as well. It's a great solution because otherwise Skanska would either have to build a new dedicated training center and have people travel there, or they have to do on-the-job training, which means putting unqualified people in a real building site to learn, and obviously that can be very dangerous. But people aren't just beginning to be exposed to XR hardware at work. We're seeing them in location-based entertainment, or LBE, as well. LBEs are an industry term that covers VR arcades. All-in-one headsets have eliminated that need for the backpack PC and are able to provide an incredible out-of-home experience. While at home, VR content is generally interacted with motion controllers. In these bespoke arcade setups, you'll encounter these incredibly immersive accessories that look and feel exactly like their VR counterparts in rooms that are bigger than what you'll ever find in a home. And now let's look at immersive glasses. Just 6 months ago, we launched the Vive Flow, a new type of device category we coined immersive glasses. While similar to AIOs, the design was heavily weighted towards form factor, weight, and portability. At 189 grams, it's lighter than the phones that are in most people's pockets. Oh. So, with its foldable design, it can fit in a bag without taking up too much space. So compared to traditional headsets that would take up the majority of your backpack space, this is the perfect companion. And it's the perfect companion for using on the go. And yeah, that's me. It's become a must-have for me on long flights. I have my own private 200-inch theater screen where I can watch any content that I can watch on my phone. Not only did we design Flow to be portable, but we also designed it to be incredibly power efficient, which means that it's so power efficient that we can just plug it straight into the USB port on a plane, and it will run indefinitely for the entire flight time. And the ease of use has also made it a great device in mental well-being and therapy as well. MindVR is one of our partners using immersive glasses for rehabilitation and helping seniors overcome isolation and allowing family members across the globe to share real-time virtual reality experiences together, especially important during a pandemic. So that's a very quick overview of the various ways these different types of VR devices are used to bring people into the metaverse. And we see them living harmoniously with each other across that spectrum. To use an analogy that's very suited for Computex, we can compare it to personal computing. If you look at the best if you're looking for the best performance, when it comes to personal computing, you're going to get the desktop. That's the same reason consumers buy dedicated PCVR headsets. If you're looking for the ultimate portability over features, that's of course the tablet. And convenience and easy to carry is the key to that design. And of course, in the middle is the laptop. There, each one is finely tuned. It's a very fine-tuned balance between features, performance, and portability. And that balancing act, when creating XR we will have it when creating XR headsets as well. We'll see those huge headsets, that make you look like a hammerhead shark. But at a certain point, if you want a higher resolution or higher field of view, you need a bigger panel, and thus a bigger headset. While we constantly innovate on new optical designs and working with partners on even more pixel-dense displays and even new optics, those limitations are still there when looking across a single generation of devices. Not to mention, higher resolution would also require more powerful components, which will require more thermal cooling and an accompanying power source. But that's enough for the hardware. I want to talk about something a little bit more interesting, which is about the system technologies powering them. To make any decent XR device, there are two very important technologies out of a lot of them: tracking and graphics performance. Let's start with tracking. The most common VR devices on the market are sold as a headset with two motion controllers. Getting both to accurately track is needed to avoid users getting nauseous. Beat Saber isn't just one of the most popular VR games, but it's actually one of the most demanding when it comes to tracking. If the accuracy is just slightly off, or that latency is just a few tenths of a millisecond off, a user can easily miss the beat that they're intending to hit. It's why it's one of the experiences that we use internally when testing our own tracking. And yeah, that's me again. All of the testing basically got me into 6th place on the Beat Saber worldwide leaderboards. A headset and two controllers only tracks my hands and my head. But for the vision of the metaverse, what about tracking the rest of the body? Well, we'll need to have more tracking points. By strapping additional Vive trackers onto the hip and also the feet, You can actually use these 6 tracking points, including your headset and controllers, and what's called inverse kinematics, to capture a full body's movement of someone actually quite well. This one isn't me. It's a dancer called Makoto. He's part of an online community called the IDA, an International Dance Association. They're quite amazing. So I want to go into a little bit. They're a dance community that's specifically in VR. During the pandemic, there was a huge influx of dancers in VR, looking to express their art in a new medium. It's genuinely amazing to see how they're able to bring together amateur dancers and teachers, and then also invite professional dancers for support and encouragement. So with additional trackers, we can quite accurately track the limbs, but what about finer motor movements? What about our hands? Using hands in VR is something that's incredibly natural. We're all very familiar with using our hands. Hand tracking has come a long way in the past few years, but it still has some way to go. One of the biggest challenges with hand tracking is just that everyone's hand sizes, their shape, and proportions are different. We have to take each camera frame, process it, figure out where the 26 tracking points are based on that image, translate that into a virtual visual representation, all within milliseconds. Oh, and also, if you want to make sure all of that you also have to make sure that tracking is extremely power efficient as well, and computationally very light, so you don't cause performance issues with the VR content itself. Earlier this year, we showed just how reliable hand tracking can be done. With our wrist trackers, we can really enhance hand tracking to the point where they can occlude one another. So for an avatar in the metaverse, we now have the body, the hand. We're still missing a crucial part, the face. The gold standard when it comes to photorealistic high-fidelity avatars right now is Unreal Engine's MetaHuman. It's the same avatar technology used in the Matrix Resurrection Unreal Engine 5 demo. And it was used to create a digital version of Keanu Reeves and Carrie-Anne Moss that looked incredibly realistic. Research shows that there's a noticeable increase in engagement and that feeling of trust when you're interacting with someone in VR who has realistic facial expressions, eye contact, and body language. We already have headsets with eye tracking and facial tracking. Here's a demo of Vive Pro Eye with our facial tracker, hooked up to a MetaHuman avatar. The lower face tracking alone accurately tracks 38 different blend shapes across your cheeks, chin, jaw, lip, teeth, and your tongue. And if you pair that with the eye tracking, your avatar quite reliably conveys your real facial body language. And that includes the one time a colleague caught me rolling my eyes in a virtual meeting. We'll soon release the blueprints to integrate our face tracking technology with MetaHuman. But we're all about choice. You can have your avatar be super realistic if you really want to through MetaHuman. But we also support VRM avatars. Those are an open standard when it comes to avatars in VR, where you can create anything you like and take it with you across a variety of content seamlessly to better represent yourself. So that was tracking. Let's talk about graphics, right? That's incredibly important when it comes to XR. And XR, VR in particular, has a really high bar when it comes to graphics performance. High resolution and high sampling are needed for a really high fidelity experience, but we also need low latency and high refresh rate so users don't get sick. These are similar to normal gaming, but VR has one key requirement that normal gaming doesn't have. Don't drop frames, or the user's going to feel very nauseous very quickly. I mentioned earlier PCVR for those that want the best visuals, but how different is it from an all-in-one? So let's take this high-end gaming PC as an example, and which of course requires some RGB so that it can really maximize that performance. Depending on the specs, but a high-end PC could use over 800 watts over full load. Now, compare that to the 10-watt TDP of a Qualcomm XR2 chip that you can find in the current generation of all-in-one headsets. It's really miles apart. Let's take a look at the scene from Museum of Other Realities, a PCVR-only VR content. The crazy number of particles, the size of the scene, the lighting, this piece of art would be almost impossible to experience well on current all-in-one VR headsets. So how do we bridge that gap? Let's look at the scene. So the way we're going to do it is through VR streaming, right? So remote rendering, or PCVR streaming, has brought the ability to run PCVR content on all-in-one headsets. But it's not just as simple as a video stream being sent to the headset. It's actually rather complex. Special technologies are needed for video encoding, that decoding process to maintain a low latency. Reprojection techniques are needed to hide latency from that entire process, plus the transmission time. As I mentioned, the current techniques are basically running a PCVR content and sending it to the headset. So what's next? We're also working on something that's a combination of PCVR streaming and local rendering on the headset. And that's called split rendering. Let's take this scene as an example. Also from Museum of Other Realities. A lot of environments, a lot of the environment here isn't actually too difficult for the mobile processor in an all-in-one to render. But the artwork, on the other hand, would be a challenge to render in high fidelity. So with split rendering, we can split these two parts into to be rendered in two different places. With some fancy magic, we can basically combine them locally seamlessly, with the surroundings and the adjacent avatars rendered locally, so they aren't as susceptible to the added latency of cloud computing. This allows for an optimal use of computing resources, especially as GPU computing in the cloud becomes more and more accessible. This will even be more important for augmented reality. So with AR, that vision, mind the pun, is having something that resembles today's glasses. That means minimizing computing power and battery on said device. So some 3D virtual objects will be pretty reliant on split rendering. And of course, to deliver that, we also have to talk about infrastructure. And let's start with connectivity. We now have some really incredibly high-speed wireless connectivity technology there that's available for consumers to use. And they've been able to deliver great VR experiences as well. Vifocus 3 is, and as far as I know, the only VR headset that supports Wi-Fi 6E, allowing our users to really take advantage of the expanded clean spectrum to deliver high-quality experiences. With 5G, the technology is shipping out to more and more users, being able to deliver not only higher speeds, lower latency, but also higher user capacity while achieving the first two mentioned features. We consider it so important that we spun off our 5G team into its own business unit called G-Rains. G-Rains specialize in the software and infrastructure optimizations for private 5G networks. The team recently launched Raincore. It's a complete hardware solution, a hardware and software solution for deploying 5G. That's the size of a medium suitcase. You can basically check it onto a plane. We work with SI partners on the hardware side. We didn't build that ourselves. And building upon 5G open standards, that's how we were able to deliver such a solution. We demoed it at MWC and CES this year, both times running multiple VR users with content being delivered, rendered on a remote server. And last year, we deployed a private 5G network in our Viveland VR arcade in Kaohsiung. To deliver good VR experiences to wider audiences, higher quality connectivity and infrastructure is key. So XR has huge momentum. It's enabling so many different experiences, and so many industries are benefiting from it. But for that momentum to keep going, and for XR to fully enter the mainstream, hardware and software need to keep evolving together. We've been aware of that since day one. We made strategic investments across various business units. Our Vive Arts team helped the Louvre to put on their first ever VR exhibition, giving a unique up-and-close look at Da Vinci's Mona Lisa. And our ViveX incubator has invested over $100 million in the last 6 years, including a company called Emissive, who earlier this year worked with Orange to unveil one of the most detailed experiences of the Notre Dame. Elsewhere, our Viveport team continues to create one of the world's best hardware-agnostic experiences. A platform which has thousands of pieces of content from developers all over the world, and which any headset can access via a PC. Bringing all of these hardware, software, and service elements together is what we see as being critical to the future of XR in the metaverse. All of this experience has kind of driven us to create Viveverse, a rapidly evolving experience where people can socialize, work, and have fun. But most importantly, it's built around the ideas of openness and collaboration. As I said at the start, XR in the metaverse is far bigger than any single platform or technology. And all of us have a responsibility to ensure it's for the people and by the people. Thank you.